Okay, we're going to have a look in this screencast at exponential functions and what they look like when they're graphed. So what we mean by exponential functions are functions that look like this: y equals, for instance, 2 to the power of x. So this is the feature here. This is the feature having the x, the unknown, in the power. So what we're doing is we're looking at, as the power changes, with the base being in this case 2, we'll look at variations on that, but when the base is fixed and we change the power, so now the horizontal axis is x. So as x changes, what's happening to our function? So it's got some quirky features, and as we did with circles, let's develop it and have a look. Like any graph, we don't know how to start it, but we sure know that we can just get some points together, and once we've got enough points, we'll have an idea of what this thing looks like. So some pretty obvious points first up. X equals 0 is a pretty obvious one. Again, I'm going to go in here just to leave some room either side. Now when x is 0, 2 to the power of 0, do you know what that is? Well, hopefully back to our work on indices, and this is what we're doing. We're looking at indices here, aren't we? We're looking at the changing values of x. 2 to the power of 0, anything to the power of 0 is equal to 1. So that's a nice easy point, isn't it? 0, 1, that's in there. So that's where it's a start. Now what happens beyond 0? So as x gets larger, x equals 1, 2 to the power of 1, that's 2. 2 to the power of 2, that's 4, isn't it? 2 to the power of 3 is 8. And this is where we get some features starting to come out, and you can see as it gets larger, wow, it's growing exponentially. So it goes across 1 and up 1 initially, then it goes across 1 and up 3, then it goes across 1 and up 4, and so it just keeps getting steeper. So this part of the curve does that. Okay, that's fine. What happens here? What happens in this bit? What happens when x is negative? Right, what happens when x is minus 1? Now this will test you out. 2 to the power of minus 1. 2 to the power of minus 1, what's that equal to? Remember that a negative power becomes positive when you've put it into the denominator. So 2 to the minus 1 equals 1 over 2 to the positive 1, so that's a half. And 2 to the minus 2, so I'll put a half in here. I know I've got minus 1, so I'm in there somewhere. When x is minus 2, 2 to the minus 2, I'll put minus 2 in here. What happens? 1 over 2 squared, isn't it? That's 1 over 4. So just as we're growing exponentially here, we're shrinking exponentially here, because now we're going to a quarter. 2 is a quarter, 3 is an eighth, and you can see it's getting really close to, but will it ever get to 0? Put the largest negative number you like in there. All you're doing is creating this 1 over 2 to this astronomical figure. 1 over an enormous value just makes it really, really small. So what we end up with here is what's called an asymptote. The x-coordinate, the x-axis, is an asymptote in that, what's an asymptote? An asymptote is a line that a curve gets closer to but never actually reaches. So the x-axis is the x-axis is an asymptote. Asymptote, there's a P in that word, asymptote. It's a little buffer zone. The curve gets closer to it, never quite reaches it. Goes through 1 there on the y-axis, goes up like that. So this is the graph of y equals 2 to the power of x. It's got that sort of shape. It's a bit messy, isn't it? I haven't drawn that particularly well, but I think you know what I mean. If I was to go in and show you on here, there it is there, 2 to the power of x. There it is. Maybe I'll drag this down a little bit. It's this one here. That's 2 to the power of x there. Okay, what I've got with it is, you see it's going through 1. What I've got with it is this function here, minus 2 to the power of x. That's this one here. So when we put a minus out the front, what that does is it reflects in the x-axis. So we should note that as well. So that's y equals 2 to the power of x, and we might just in green come down here and reflect it. And this is y equals minus 2 to the power of x. So we're just taking the negative now. This minus just is that if I've got a 1 here, I've got a minus 1 now. So all my y coordinates have got the opposite sign. So this goes through minus 1. So the negative out the front flips over the x-axis. And there's one other thing I want to show you, and that is when the x in the power becomes negative. So now I'm talking about y equals 2 to the power of minus x. So what happens there is that my y equals 2 to the power of x, which is this, right? That's y equals 2 to the power of positive x. When the minus goes in, gets inserted into the power, that flips it, that reflects it over the y-axis. So when the minus comes down the front, it reflects in x. When the minus goes up into the power, it reflects in y. So this thing gets inverted here in y. So it comes down now like this. So it's back to front there, and that's y equals 2 to the power of minus x. Only one other thing to say, really, we've looked at those variations. It's just as this number 2 changes, as it gets larger, it'll just get steeper. So as 2 gets larger, it'll just get steeper and steeper. And you know, our language for parabolas was narrowing. This is not really narrowing, it's just getting steeper as 2 grows in value. I might just show you that on Sketchpad. Just a moment, I'll pause. Okay, I've just brought Sketchpad up just to show you the effect of changing this value of what I've called A. You see up here at the top left of the screen, A is 2, which means I've got the graph here of y equals 2 to the power of x, and you can see in the thinner purple line, purple sketch, you've got minus 2 to the power of x just being flipped in the x-axis. So what happens to this as we change this curve here, as this value of A, the number in front of, or sorry, the base changes. So it goes from 2 to the power of x to 3 to the power of x to 4 to the power of x. And as I mentioned a moment ago, it just gets steeper, and you can see what's happening there. It's fanning out. It's not going particularly quickly. It hasn't even made 3 to the power of x yet, but that's what happens if we keep doing that. And I could put a 1 in front of that to make it 13 to the power of 10, and you can see it just gets steeper and steeper. It drags along the asymptote a bit longer, still all going through 1 though. Every single one of these goes through 1. It just makes it steeper. Right, as we go the other way, we find, all right, I've got to speed this process up a little. We get back to 2. As we go the other way, you can see now as we get less than 2, it just gets wider or flatter. Interestingly, as it gets closer to 1, let's have a look at what happens here. Still going through 1 on the y-axis. Now what happens it's almost a straight line here, and at 1 it is a straight line because we now got a base of 1, and 1 to the power of anything equals 1. So that is just the line, the straight line, y equals 1. Okay, but that's just as an aside. You get the idea of what's happening, hopefully, as we change the base, the value of the base that's being raised to the power of x. Okay, that'll do us. That's really all we need. We're just going to get some practice at that in our lesson on Friday, so I'll see you then.